Good evening, children.
Good evening, ma'am.
Good evening.
Good evening.
Good evening, children. Yeah. I've shared my screen. Visible, right?
Yes, ma'am.
Very good. Yeah. So last class, I think we took up a brief introduction to simple interest and compound interest. I don't remember introducing you to the formula to find compound interest. So let me just tell you that first before we take up this question.
This is Aishwarya. I wasn't there for a couple of classes due to my exams. So, should I just start continue with whatever you're doing?
Yeah, share the recordings, right, with you. You should have watched them.
Yes, I was only able to watch a few, ma'am.
Yeah, yeah, yeah. So whatever you missed is there in the recordings. So please watch them so that like make sure you have not missed anything. Yes, children. So simple interest. How do we find simple interest? Simple interest is equal to principal into time into rate divided by 100. Simple interest is equal to principal into time into rate divided by 100. A rate is always given as a percentage per annum. So say rate is equal to 6% per annum. Okay, per annum meaning for a year. And time should always be substituted in years. In years. Supposing the time is given as 73 days. All right, 73 days. Then you should convert this to years. So time is equal to 73 days or 73 divided by 365 years. Right? Or if time is given in months, say 3 months, time is given in months, 3 months. So 3 divided by 12 or 1 by 4 years. If it's given in years, you can take the value directly. So if time is given to be, say, 2.5 years, take it directly, 5 by 2, 5 by 2 years. If it's given in weeks, supposing the time is given in weeks, say 13 weeks, all right? So divide by 52, 13 divided by 52, because uh, 52 into 7 is equal to 364. 52 weeks into 7 days is equal to 364 days. All right. So a year has 52 weeks and 2 extra days, 1 or 2 extra days, depending on if it's a leap year or a non-leap year. Okay, but that's just ignored. All right. A year has 52 weeks. Though there are 2 days extra, 1 or 2 days extra, we just take it as 52 weeks. 365 days in a non-leap year and 366 days in a leap year. 52 weeks into 7 days is equal to 364 days. 364 days. So 1 year has 52 weeks, which is 364 days. All right. So if if time is given in weeks, okay, so like I said, 13 weeks or whatever, if time is given in weeks, divide by 52 to convert it to years. 13 weeks divided by 52 weeks. So 13 ones are 13, fours are 52. So 1/4 of a year. 1/4 of a year. So if time is given in days, all right, so 73 days, then divide by 365. I think 73 into 5 is 365. Yeah, yeah, correct. Normally the numerator, supposing the time is given in days, the numerator is normally, a multiple of 73. Because 365 is a multiple of 73. 365 is a multiple of 73. Normally, I'm saying normally, all right? So maybe 146 days. So then it is 73 twos are. 73 twos are 146. All right? So if time is given in years, you can take it straight away. If time is given in months, divide by 12 to convert it to years. If it's given in weeks, divide by 52 to convert it to years. And if it is given in days, divide by 365 to convert it to years. So time is always, in this formula, time is always substituted in years. So P, principal, is in terms of money, right? So rupees. So principal is the money there. So in rupees, time should be substituted in years, and rate as a percentage. Rate of interest as a percentage divided by 100. So this is the formula to find the simple interest. Simple interest is equal to PTR by 100. So time should be in years. In years, so you should divide by 52 or divide by 12 months or divide by 365 as the case may be. All right, 52 weeks, 12 months, 365 days to convert it to years. So this is simple interest. This is the formula to find the simple interest. So the amount will be equal to simple interest plus principal, or principal plus simple interest. Amount is equal to principal plus simple interest. Now the formula to find the compound interest is amount is equal to, so in the case of compound interest, we have the formula to find the amount. We find the amount and then we find the compound interest. So amount is equal to P into, the P is the principal, into 1 plus R by 100. Again, rate by 100 to the power of N, where N is the number of, where N is the time period. Okay, again in years. N is the time period, again in years. R is the rate of interest and P is the principal. So when you use this formula, you will get the amount. So compound interest will be equal to amount minus principal. Compound interest is equal to amount minus principal. In the case of simple interest, you can find the simple interest straight away. PTR by 100 will give you the simple interest. And to find the amount, it is principal plus simple interest. But in the case of compound interest, you'll find the amount using the formula P into 1 plus R by 100 to the power N. You'll get the amount. And then the difference between the amount and principal will give you the compound interest. Yeah. Look at this question. I borrowed rupees 12,000 from Jamshed at 6% per annum simple interest for 2 years. Had I borrowed this sum at 6% per annum compound interest, what extra amount would I have to pay? All right. So, well, if you find the simple interest, I'll just get you started. You need to write out P, which is 12,000 rupees, 12,000. Rate of interest 6% per annum, and time is in years, 2 years. All of you, please find the simple interest and tell me. SI is equal to PTR by 100. Work this and tell me the value of SI. Please write the question. Don't be in a hurry. Write down the question first and then find SI for me. Yeah, Amy, kindly disable your mic. Yeah.
Can I see the answer?
Yeah.
It's 1,440.
Correct. 1,440. Saujanya, is it?
Yes, ma'am.
Yeah, correct. 1,440. So if 12,000 is borrowed for 2 years at 6% per annum simple interest, then the money to be returned at the end of 2 years is 13,440. The principal value of 12,000 plus the interest of 1,440 for 2 years. When you return, we have to return the principal money of 12,000 along with the interest, because we have used the money for 2 years. Somebody's money, we have used that money for 2 years. So when you return it with the interest. So you need to return 12,000, the principal money which you borrowed, plus the interest for using that money for 2 years, which is 1,440. So the money to be returned at the end of 2 years under simple interest is 13,440. Now we need to find the amount that is to be returned at the end of 2 years if 6% is charged under compound interest. This is the formula. Amount is equal. So here you get the amount directly. Amount is equal to P into 1 plus R by 100 to the power N. Principal is 12,000. The money borrowed is 12,000 into 1 plus R. Rate is 6% per annum compound interest, right? So 6% is the rate of interest by 100 to the power N. Time, number of years. N is the number of years, the time period, 2 years. I'll just continue here, children. Okay, that's equal to 12,000. So you can simplify 6 by 100, you can simplify. So this is going to be 2 3s are and 2 50 times. All right. So this is 12,000 into 1 plus 3 by 50, the whole square. Now take up the LCM. Take up the LCM. So it's going to be 50 is the common denominator. So 50 plus 3. 50 plus 3 the whole square. 50 plus 3 the whole square. So 12,000 into 50 plus 3 is 53. 53 by 50 the whole square. So it is 53 by 50 into 53 by 50. 53 by 50 the whole square. So 53 by 50 into 53 by 50. Children, you cannot cancel 50 and 50. You cannot, because it's addition there. It's 50 plus 3. If it was, supposing the case was 50 into 3 by 50, then you can cancel 50 and 50. When the connecting sign is plus or minus, you cannot cancel like this. You have to add or subtract. You'll have to add 50 plus 3 or 50 minus 3. You need to add or subtract. So when it's plus or when the connecting sign is plus or minus, you cannot cancel the 50 in the numerator and denominator. So you cannot do this. So you have to add 50 plus 3, 53. So 53 by 50, the whole square. So 53 by 50 into 53 by 50. Yeah, please work this. Simplify and tell me the value of A.
Mama, I got 337,080.
No, darling. For A, is it, Aishwarya?
Yes, and for A.
No, ma. I have a different value. It should be a little.
Oh,
It
I actually forgot to cancel. Yeah, 1 second.
It should be a little more than 12,000. That's all. 12,000 is the principal, right? So something more than 12,000, a little more than 12,000.
Ma'am, I'm getting the answer is 13,483.2, and then the compound interest is 1,483.2.
Correct.
Yes, ma'am. I'm also getting the same thing.
Correct. Yes. So you can, we'll simplify 0, 0, 0, 0, 0, 5 ones are 5, 2s are 10, 4s are 5 4s are 20. And then no, you cannot simplify any further. I'm using the calculator. 24 into 53 into 53 is 67416 divided by 5. Divided by 5. All right. Divided by 5. Yeah. So it's exactly 13483.2. 13483.2. 0.2 meaning 20 paise. So for 12,000 borrowed for 2 years at 6% per annum compound interest, the money due at the end of 2 years will be 13,483 rupees 20 paise. This one includes 12,000 and the interest. This is the amount. And the compound interest, you find the amount directly. A is equal to P. A is equal to amount is equal to P into 1 plus R by 100 to the power N. So this one, 13,483.2 is the amount directly. Amount is inclusive of principal and compound interest. Amount means it's the principal plus the compound interest. So 13,483.2 has 12,000 in it, the principal money, and that extra portion is the compound interest. So this is the money due. 13,483.2 is the money due at the end of 2 years under compound interest. Now, what is the question? What extra amount would I have to pay? So the difference in the amounts, or if you found the interest, you can find the difference in the interest. See, the difference in the two interests, that is CI minus SI, or the difference in the two amounts will give you the extra amount you have to pay. So difference in amount is equal to 13,483.2 minus what's the amount to be repaid under simple interest? 13,440. See, you can, to find the difference in amount, you can work CI minus SI, or you can work the amount under compound interest minus the amount under simple interest. Both will give the same answer. Because the difference is going to be only in the interest portion, the interest, right? The principal value is the same, 12,000 you have to return. The difference is because of simple interest and compound interest. You can work this one, that is what you see on the screen, amount under compound interest minus amount under simple interest. Or you can also find the compound interest. How do you find the compound interest? Amount minus principal. You can find the compound interest, amount minus principal, and then work CI minus SI. That also will give you the difference in the money paid. Yeah. So this is 440, this is 483.2. So how much is that? 48 rupees. Oh no, 83, sorry, 43 rupees. Yeah. So the difference is rupees 43.2. Got this?
Yes, I got this answer.
Yeah. So the extra money to be paid under compound interest is 43 rupees 20 paise. Read the question and please write the values against P, R, and T. T in simple interest is N in compound interest. N to the power N. N is the number of years. N is number of years, which is the value of T, 2 years. So find the simple interest and then find the amount. When you use the compound interest formula, A is equal to P into 1 plus R by 100 to the power N, you get the amount directly. The difference in the two amounts is the difference in money to be paid, the extra amount to be paid. Yeah. Done, children? Shall we go to the next one, children?
Yes, ma'am.
Okay. Yeah. Vasudevan invested rupees 60,000 at an interest rate of 12% per annum, compounded half yearly. Compounded half yearly meaning normally the interest is calculated yearly, annually. See, now 12% is the interest in this question. Normally, the interest is calculated at the end of every year. But here, compounded half yearly meaning interest is credited at the end of every 6 months. Every half a year. At the end of every 6 months, interest is given. See, the interest is 12% per annum. So for half yearly, the interest will not be 12%. 12% interest is given for 1 year. So for half a year, the interest will be only 6%. Okay, so here under compound interest, we have a formula to find the amount when the interest is compounded half yearly. So let me read the question fully. Vasudevan invested rupees 60,000 at an interest rate of 12% per annum, compounded half yearly. So compounded half yearly meaning interest is paid at the end of every 6 months. Every 6 months, interest is calculated on the money you have in the bank and it's credited to your account. Interest is credited at the end of every 6 months. So at the beginning of the 7th month, you have a new value in your account. And for the and from there on, at the end of 6 months, interest is calculated on that value, which was at the beginning of the 7th month. Okay, now the question is, what amount would he get after 6 months, after 1 year? After 6 months, after 1 year. See here. Principal, rupees 60,000. Rate, 12%. And time in the first case, okay, in the first one, okay, this is for the first one. Okay, time because it's compound interest, let me take n. N is equal to 6 months. But we know that we should not substitute time in months or days or weeks. It has to be substituted in years. So this is 6 by 12 or half a year. Okay. See this one. After 6 months, what amount would he get after 6 months? So we are answering this one first. Principal 60,000, rate of interest 12%, and it's compounded half yearly. Interest is calculated every 6 months. Under these circumstances, what will be the amount Vasudevan would get after 6 months? If he visits the bank after 6 months, what will be the amount in his account is the question. That is, there will be the principal value of 60,000 and some interest also will be given to him, no, because interest is given every 6 months. So if he visits the bank after 6 months, if interest is given yearly, if interest is compounded per annum, if interest is given yearly, in that case, if he visits the bank after 6 months, he'll only see 60,000 in his account. He will see only 60,000. If interest is compounded yearly, he deposits 60,000 in the bank and he visits the bank after 6 months. After 6 months, he'll see the same money in the bank because interest is interest will be given only at the end of the year. So if he visits the bank after 6 months, he'll see the same money, 60,000. But in this case, where the interest is compounded half yearly, interest is given every 6 months. So when Vasudevan visits the bank after 6 months, he will see this money of his money 60,000 plus the interest which is given. That's what you'll have to find. What amount would he get after 6 months and then after 1 year? For both these, interest is given half yearly. Interest compounded half yearly for both the subdivisions 1 and 2. Okay, now we are working 1. 60,000 is the principal, rate 12%. N is 6 months, children. N is 6 months, but time should not be substituted in months. It should be substituted in years. So 6 by 12, half a year. Now, because it is half yearly, we will not use this formula. We will not use this formula because it's half yearly. We'll not use this formula. We have another formula if it's half yearly. And what is that? Amount is equal to P into 1 plus R by 2 into 100 to the power 2n. If it is half yearly, this is the formula. Now, how did we get this number 2? Because how many 6 months in 1 year? How many 6 months in 1 year? 2 6 months. That's how we get this number 2. How many 6 months in 1 year? 2 6 months. 6 plus 6. 2 6 months in a year. So 2. Amount is equal to P into 1 plus R by 2 into 100 to the power of 2n. 2n because interest will be given twice, right? Twice interest will be given. 1 year once usually, but this is after 6 months. So in a year, twice it will be given. But the rate of interest will not be 12% for 6 months. It will be only 6%. That's why R by 2. That's why R by 2. This is the formula which you have to remember if the interest is compounded half yearly. The number 2 you see in this formula is because half yearly meaning 6 months and there are 2 6 months in a year. That's how we get this number 2. So the formula will be A is equal to P into 1 plus R by 2 into 100 to the power 2n. Now let's just imagine interest is given every 2 months. Interest is given every 2 months. Interest is given every 2 months. Every 2 months. How many 2 months in 12 months? How many 2 months in 12 months? Tell me.
6.
6. So then the formula will be A is equal to P into 1 plus R by 6 into 100 to the power 6n. Because you would ask me, okay, if it is half yearly, this is the formula. What if it is like 3 months, 4 months, or 2 months? This is how you do it. Just ask yourself if the interest is compounded every 2 months. Every 2 months, the bank gives interest for the money in your account. So supposing you keep the money at the beginning of January. Okay, beginning of January. So Jan, Feb end, interest is given on the principal money you have in the bank. So when you visit the bank, on 1st March, you will see that your money in the bank has increased because interest was given at the end of the 2nd month. End of February, interest was credited. So March, beginning of March, you will see your principal money and the interest. Now March, April. At the end of April, again interest is given on the money in the bank at the beginning of March. So if you visit your bank in May, on May 1st of May, you will see that your money has further increased because interest is given every 2 months. So at the end of April again, interest was credited on the principal money which was in the in the bank at the beginning of March. So like that, every 2 months interest is given on the money you have in your account. So at the end of every 2 months, your money keeps increasing in value. Yeah. So how do you, generate the formula under different circumstances? So if interest is given every 2 months, how if interest is given every 2 months, how many 2 months in 12 months? Why 12 months? Because 1 year, 12 months. So how many 2 months in 12 months? 6. So it is R by 6 and N into 6. R by 6, N into 6. Now supposing interest is given every 3 months. Every 3 months. So how many 3 months in 12 months? How many? How many 3 months? Yeah. So how many 3 months in 12 months? 3 into 4, right? 3 into 4. So 4 times you get. 4 times. So 3 months, 3 months. So it's like 3 plus 3 plus 3 plus 3. Interest is given at the end of 3 months, again at the end of 3 months, again at the end of 3 months, again at the end of 3 months. So this is a year. 4 times interest is given. That's how the number 4. So then it will be R by 4 and N into 4. Okay. So you will not get a situation like what if it is credited every 5 months? You will not, don't worry about the situation. So it can be every month, every 2 months, every 3 months, every 4 months, ignore 5, every 6 months or every 12 months. Every 12 months is 1 year, once in a year. Okay. So here it is every 6 months. So 2 6 months in a year. So the number is 2. Modify the formula. R by 2 into 100. Divide rate by 2 and multiply time by 2. N into 2, R by 2. This is the formula. Now substitute the values. So P is 60,000 into 1 plus R. Whatever is R here, children. Whatever is R given in the question, the formula is modified. Now don't further modify the numbers in the question. We have taken a modified formula. Substitute the values as given in the question. Substitute the values as you see in the question. We have modified the formula. So P is 60,000 into 1 plus R. What do you see R in the question? 12. 12 it will be. What do you see R in the question? 12. So 12 by 2 into 100 to the power. What is N? What do we see N in the question? After 6 months. No, time is 6 months. Time is 6 months. But since we shouldn't substitute time in months, we converted that to years. So half a year. Half. N is half. N is 1 by 2. 2N. 2 into 1 by 2. The question is what amount would he get after 6 months? So N is 6. 6 months. So 6 by 12, half a year. So N is 1 by 2. In the formula, you should substitute N as 1 by 2. R 12. P 60,000. Now 60,000 into 1 plus, you can simplify. 2 1s are 2 6s are. Then further 2 3s are 250 times. So you'll have 1 plus 3 by 50 children. 1 plus 3 by 50. You can see there. Okay. So 1 plus 3 by 50 to the power 1. To the power 1. So 60,000 into on taking the LCM. Now you know you'll get 53 by 50 children. Take the LCM. You'll get 53 by 50. If you want me to show that step. That's equal to 60,000 into 50 plus 3 by 50 to the power 1. You can just ignore it. You don't have to show 1. So 60,000 into 53 by 50. Yeah, calculate this, children. This is the money Vasudevan will get after 6 months. In this question, interest is compounded half yearly. So you should use this formula only for both the cases. For both the cases, use this formula because interest is compounded half yearly. Both the cases meaning subdivision 1 as well as 2.
I got the answer, ma'am.
Yeah, tell me.
63,600.
Correct. 63,600 is correct. Yeah. So Vasudevan would get 63,600 after 6 months. Now, under the same situations, 60,000, 12% compounded half yearly. What is the money he will get after 1 year? Same conditions. 60,000, 12% compounded half yearly. What is the money he will get after 1 year? So because it is compounded half yearly, use this formula again. Use this formula. But the time is n 1 year, 1. N is 1. Okay, for the second one, principal 60,000, rate 12%, n is equal to is given there 1 year, after 1 year. So n is 1 year, 1. All right, amount is equal to P into 1 plus R by 2 into 100 because it is compounded half yearly. Interest is compounded half yearly to the power 2n. 60,000 into 1 plus rate 12 by 2 into 100 to the power n is 1, 1 year. So n is 1, 2 into 1. So 60,000. Do not cancel these two zeros and these two zeros, children, now. Now, don't cancel because there's plus here. 1 plus 12 by 2 into 100. You need to simplify this first and then cancel the zeros, not now. If you do this, you'll go wrong. 2 ones are 2 6 are 2 3s are 250 times. So 1 plus 3 by 50 to the power 2. 60,000 into, so on taking the LCM, you'll get 53 by 50. So 53 by 50 into 53 by 50 because the whole square. So write it 2 times. Simplify this and tell me the value, children.
Ma'am,
Yeah.
first I did this sum wrong. First I did it wrong. I did it the you know I wrote to the power 2, so I got this question's answer. The
Oh,
answer is 7,416.
yeah, for this one, yes. Correct. So here you need to write Vasudevan. Vasudevan will get rupees 63,600 after 6 months. Here, Vasudevan will get rupees 67,416 after 1 year. Done, children? All right. Next one. Yeah. Arif took a loan of rupees 80,000 from a bank. If the rate of interest is 10% per annum meaning for a year, if the rate of interest is 10% per annum for a year, find the difference in amounts he would be paying after 1.5 years if the interest is compounded annually, compounded half yearly. So this person takes 80,000 rupees loan from a bank and he wishes to return it after 1.5 years. After 1.5 years, he'll return the money. So when he returns, he'll return 80,000, the principal value of 80,000, along with the interest, which is charged at 10% per annum. Now we need to find, so principal value 80,000, rate of interest 10%, time 1.5 years. Two cases. What is the money he will pay if the interest is compounded annually, that is yearly? What is the amount he would pay if the interest is compounded half yearly? And what is the difference in these two amounts? What is the difference in these two amounts? Is the question. Principal money, that is the loan, value of loan is 80,000, rate of interest 10% for 1 year, and time period 1.5 years. Time period is 1.5 years. Okay. Now, what he returns after 1.5 years is the amount, because it's a principal plus the interest. It's the principal plus compound interest. So what he returns at the end of 1.5 years is the amount. Now, what is the amount he has to pay the bank if the interest is compounded annually? That's the first subdivision. What is the amount he has to return if the interest is compounded half yearly? And finally, you should find the difference in these two amounts. Find the difference in these two amounts. Right? Okay. Okay. Now, when the time is a fraction, you have a formula again. When the time is a fraction, because in this formula, where do you substitute time? To the power of n, right? To the power of n. N is the time there, number of years. Now, the power, if it's a fraction, it's difficult to compute because, say, if you have to find 2 to the power 3 by 2, 2 to the power 3 by 2. What is the power? Power says how many times the base has to be multiplied with itself. Now, when we say 2 to the power 4, it means 2 into 2 into 2 into 2. The power says how many times the base has to be multiplied with itself. The power 4 says how many times, 4 times, the base has to be multiplied with itself. The base 2 has to be multiplied with itself. So number of times, if it's a fraction, it's difficult to compute the value. Okay, so when the time period, when number of years is a fraction, we have a formula, a different formula. So it is P into 1 plus R by 100 to the power n into whatever that fraction, for here I'll write the substitute the values and show you. See, I think I'll just tell you a general one. Now, supposing the time is say, supposing the time is say 3 by 4 years, children. All right, 3 by 4 years. So amount is equal to P into 1 plus R by 100. Supposing the rate is 12%, so 12 by 100. Okay, to the power n. N is 3 by 4. So what you do, you take power 3 here and then open a bracket 1 plus, again R by 100, right? R by 100 will be 12 by 100. Now this fraction you multiplied here. This fraction you multiplied here. Don't take any power. Don't take any power for the second bracket. Multiply this fraction, whatever is the fraction here, multiply that with the rate here. That's it. I'll repeat this. Supposing the time is 3 by 4 years, which means n is 3 by 4. Then amount is equal to P into 1 plus R by 100 to the power 3. All right, into 1 plus 3 by 4 into R by 100. That's all. Into 1 plus this one 3 by 4 into R by 100. So you can see 1 plus R by 100. Again 1 plus R by 100, but R is multiplied with this fraction 3 by. That's all. So here 1.5. So you don't have to write it as 3 by 2 actually. Don't write it as 3 by 2. 1.5 years. Okay. So A is equal to P into 1 plus R by 100 to the power 1 into 1 plus 1 by 2 into R by 100. Please tell me if I'm clear. 1.5. So take 1 here. P into 1 plus R by 100 to the power 1 here. And then in the second bracket, 1 plus again R by 100, but multiply R with 1 by 2, that fraction 1 by 2. 1 is taken here, 1 by 2 is taken here. Yeah, or substitute. P 80,000 into 1 plus R 10 by 100 to the power 1. So you can just ignore it. 1 plus 1 by 2 into R 10 by 100. All right. You can cancel this 0 and 0. 80,000 into 1 plus 1 by 100 children. 1 plus 1 by 100. Sorry, 1 plus 1 by 10. Take the LCM. So 10 is the common denominator. So it will be 10 plus 1 here. Into here 2 1s are 2 5s are children. 2 1s are 2 5s are. 1 by 2 into 10. 2 1s are 2 5s are. And again 5 1s are 5 20 times. So what do you have here? 1 plus 1 by 20. 1 plus 1 by 20. 1 plus 1 by 20. In the first bracket, you have 1 plus 1 by 10. In the second bracket, you have 1 plus 1 by 20. LCM. I'm taking the LCM, you get 10 plus 1 by 10 into 20 plus 1 by 20. LCM 80,000. 11 by 10 into 21 by 20. Please work this and tell me.
Ma'am, is the answer 92,400?
Perfect. 92,400. Yeah, 92,400. So children, what have we calculated? We have found the amount that is to be returned by RF at the end of 1.5 years when the interest is compounded annually. He has taken 80,000 from the bank. After 1.5 years, he has to return 92,400 to the bank, where the interest is compounded annually. Now work the second case, children. When the interest is compounded half yearly. So it's a different formula, children. It's a different formula. When it's half yearly, it's a different formula. See here, in the first case, what we have just worked, it's compounded annually. All right. But though it is compounded annually, the time is in fraction, 1.5 years. So again, it's a special formula. P into 1 plus R by 100 to the power 1, and then into 1 plus half into R by 100 to, find for 1.5 years. First for 1 year and then for half a year. Now for the second one, you should use that special formula. Half yearly. P into 1 plus R by 2 into 100. The whole power 2n. Do that. And then you should find the difference in the amounts. Children, use the emoji. Raise your hand. Online students. Shreya, Gayatri, Aishwarya, Lakshana, Surya, Yarni. Gayatri, I didn't see you at the beginning of the meeting.
Mom, I came first question itself, Mom.
Okay. All right. Thank you, children. Yeah. So here n is 3 by 2, 1.5 years, right? 1.5, which is 3 by 2, children. 3 by 2. 2n. See, we're using this formula because interest is compounded half yearly. Half yearly meaning 6 months. So how many 6 months in a year? 2 6 months. That's why we have R by 2 and 2 into n. R by 2 and n into 2, 2n. R is 10 given in the question. R is 10, it's given in the question. And n, what is n? 1.5 years. And what is 1.5? 3 by 2. I've simplified this. 0 and 0 you can cancel. And this 2 and 2 will get cancelled. So you have 80,000 into 1 plus 1 by 20 children. You can see 2 into 10 is 20. 2 into 10, 20 to the power 3. 21 by 23 times because the power is 3. 20 into 20 into 20. Can cancel the zeros. 3 zeros here, 3 zeros here. And then 2 2s are 4, 4 2s are 8, and 8 10s are 80. I'll not cancel because you might not be able to see the digits clearly. You do the cancelling by yourself. What is it?
Ma'am, I got the answer.
Yeah. How much is it?
Just like, let me look in my book. It is 92,610.
Correct. 92,610. See, the others are quiet. Surya, Yarni. Why don't you participate, Surya? Yarni. Lakshana is also very quiet today. Yeah, as you said, it's 92,610. Now the question is to find the difference in the amounts. So in case 1, 92,400. In case 2, 92,600. Yeah, when the interest is, calculated every 6 months, you are benefited if it's a deposit, but you're not if it is a loan. See, if you deposit money in the bank and the bank gives you interest every 6 months. Okay, instead of giving it for every year, if you get interest every 6 months, you're benefited. You'll get a little more. Because every 6 months your money increases. So the principal value at the beginning of 7th month is more. On that you will get interest again for 6 months. When interest is given frequently meaning less than a year. In 1 year, if you're given interest more than once, in 1 year, if you are given interest more than once, in the case of, half yearly, quarterly, or every month, every 2 months. So when interest is given more than once, usually it is once a year. If it's given more than once in a year, you will get a little more as interest. So you're benefited if you deposit money in the bank. If you deposit money in the bank and the bank gives you interest every 3 months or every 6 months, you will get a little more as interest when compared to getting interest every year. So if with a deposit you're benefited, supposing you take a loan and the interest is compounded quarterly. That means interest on your loan is calculated quarterly, meaning How many quarters? Quarterly meaning 3 months or 4 months? Quarterly. Every 3 months. I ask a question and I have to answer it. So supposing, so you take a loan from the bank where interest is calculated quarterly, every 3 months. Every 3 months, you know, your principal money is taken and interest is calculated. So in that case, there also interest will be more, right? So you'll be paying there. When you've taken a loan, you will not pay that interest. If it's a deposit, you will get that interest from the bank. The case of deposit, and the bank gives you interest more than once in a year. Every 3 months it gives you interest, every 6 months it gives you interest. You will get a little more as interest. So you're benefited if it's a deposit. But when you've taken a loan from the bank and the bank charges interest every 3 months or every 6 months, then you will be paying a little more as interest. So for a loan, compounded yearly is good. For a loan where you have to pay the interest, compounded yearly is good. For a deposit where you keep the money in the bank, where the bank gives you interest, here getting interest many times in a year is benefited. You are benefited there. You'll get a little more as interest. So for a deposit, if interest is compounded quarterly or half yearly or every 2 months, you will get a little more as interest. Yeah. So that's what you see here. So what happens? See the two cases. First one is compounded. This is a loan. RF has taken a loan for 1.5 years. First case, interest is compounded annually. Second case, half yearly. So half yearly, if interest is calculated, he'll be paying a little more as interest there only. And you can see the amounts. In the first case, the amount RF has to pay the bank after 1.5 years is 92,400. After 1.5 years, RF has to return 92,400 to the bank. In the first case, compounded annually. But compounded half yearly, he'll pay a little more. 92,610, a little more. So 210 rupees extra he has to pay. That is the question. Find the difference in the amounts. Find the difference in the amounts. So the difference in amounts is equal to difference. Difference in amounts is equal to 92,610 minus 92,400. That is rupees 210. 210. Finish writing?
Yes, ma'am.
Okay. Aishwarya, Gayatri, Lakshana.
I'm in the last line.
Yeah.
Yes, no, even I'm done.
Okay. Okay. Look at this one. Maria invested rupees 8,000 in a business. She would be paid interest at 5% per annum compounded annually. So Maria is investing money in a business 8,000 rupees in a business, and she would be paid interest at 5% per annum. 5% per annum meaning for a year, compounded annually only. Interest is calculated every year. Find the amount credited against her name at the end of the second year. Find the amount, not the interest. Find the amount credited, not the interest. Amount directly. So find the amount credited against her name at the end of the second year. Then find the interest for the third year. Find interest only for the third year. All right. Yeah. It's compounded annually, so it is 1 plus r by 100 to the power n. Yeah, what's the answer?
8820.
8820. Correct. 8820. So the amount credited against Maria's name at the end of 2 years. At the end of 2 years or second year, at the end of the second year, is rupees 8820. So this is the amount that will be credited against Maria's name at the end of 2 years, at the end of the second year, or at the end of 2 years. So she invested only 8,000 rupees. But at the end of the second year, the amount in her account is 8,820. So she's got 820 rupees as interest. Now you'll have to find the interest for the third year alone. For the third year. So when you're calculating the interest for the third year, the principal will be the money in the account at the end of the second year. In the case of compound interest, the principal money will keep increasing every year. When interest is compounded yearly, every year the principal value would have increased. So when you're calculating the interest for the third year, the principal will be the money at the beginning of the third year, the money in the account at the beginning of the third year. And what will be the money in the account at the beginning of the third year? Whatever was at the end of the second year. Whatever was at the end of the second year will be the money in the account at the beginning of the third year. And that's nothing but 8,820. 8,000 is the principal when she started off. Now she's come down 2 years. So it's not 8,000 anymore. Now her money is 8,820 at the end of the second year. So this will be the principal for the third year. The principal for the third year will be 8,820. And since you're finding the interest for the third year, it's only 1 year, it's not 3. You're finding the interest for the third year. So time is 1. Because third year is only 1 year. Third year is only 1 year. Third year is not 3 years. You're finding interest for the third year, which is only 1 year. So T is equal to 1 year and rate of interest is 5%. 5%. Now what you need to understand is when the time is 1 year or less than 1 year, simple interest and compound interest value will be the same. Simple interest is the same as the compound interest. If the time is less than 1 year and interest is also compounded annually. When interest is compounded annually and the time period is 1 year or less than 1 year, simple interest and compound interest will be the same. All right. Principal is 8,820 because that's the money at the end of the second year, and that will be the principal for the third year. Time is 1 year because the third year is only 1 year, rate is 5%. Now we need to find the interest credited, interest for the third year. So you can find simple interest itself because compound, even if you put it in compound interest formula, you'll get the same value as simple interest. You can work both. You can work both. So you can directly find the simple interest. What is the simple interest? Principal into time into rate by 100. Principal is 8,820 into time into rate by 100. So this will be the interest credited for the third year. You can do it like this, or you don't use this formula. I'm just trying to show that both will give you the same result.
I'm getting the answer is 4.
Yeah, Tim. Yeah, tell me.
I'm getting the answer is 440.
Tell me. How much?
440.
Okay, 1 second. Yeah, 441, right?
Yes, sir, I'm getting the same answer.
Yeah, good. So you can see when the time is 1 year or less than 1 year, and the compound interest is also calculated annually. When CI is calculated annually and the time is less than 1 year or less than 1 year, simple interest is the same as the compound interest. So to find the interest credited for the third year, which is 1 year, you can use the simple interest formula itself, PTR by 100. So you will get the interest directly. 441 rupees interest will be given for the third year. For the third year. If you use the amount, this formula, you will get the amount 9261. But the question is what interest is credited for the third year? So interest is amount minus principal. 9261 minus 8820, which is 440. You can do it like this, but you can see that you have more steps here, more calculation. So you can save time by doing this. It's a or. You can do it this way or this way, but this only you should do. Or method, don't do. Or is just to understand. You should do this one only. When time is 1 or less than 1 year and the interest is compounded yearly, simple interest is the same as the compound interest. So the interest for the third year is rupees 441. Got it, children?
Yes,
Okay. Done, children? Just give me 10 more minutes, children. I'll wind up the session. Look at this question. Ram buys a refrigerator for rupees 4,000 on credit, meaning on loan. It takes a loan. Ram buys a refrigerator for rupees 4,000 on credit. The rate of interest for the first year is 5% and the second year is 15%. How much will it cost him if he pays the amount after 2 years? So the principal loan value is 4,000. Okay, the interest is 5% for the first year and 15% for the second year. Now, under these conditions, if he returns this 4,000 rupees, okay, returns meaning he has taken on loan. So if he pays this money under these interest rates, after 2 years, he will not pay 4,000. He has to pay more than 4,000 because he's not paid cash upfront to buy the refrigerator. He has taken it on credit. So he'll take home the refrigerator, but he'll pay the money for the refrigerator only after 2 years. And he'll not pay 4,000 after 2 years. He has to pay a little more. So what is that more amount? What is that amount which he has to pay after 2 years? If the rate of interest is 5% for the first year and 15% for the second year. So for this, when we have different rates for different years, we have a formula, children. Okay. So P is equal to here 4,000. R1 is equal to 5%. Once again. Principal is equal to rupees 4,000. R1 is equal to 5%. R2 is equal to 15%. And N is equal to 2 years. Okay. Amount is equal to P into 1 plus R1 by 100 into 1 plus R2 by 100. See, this is for the first year, this is for the second year. So don't put 2 here. This one, the first bracket is for the first year, second bracket for the second year. So the power is 1 in both the cases. The power is 1 in both the cases. No power here. Don't put power 2. This is only for 1 year. This is for 1 year. So the power is 1 for both. So you don't have to show the powers. Amount is equal to when you have different rates of interest. So amount is equal to P into 1 plus R1 by 100 into 1 plus R2 by 100. So that is 4,000 into 1 plus 5 by 100 into 1 plus 15 by 100. You need to work this and find the money he has to pay after 2 years. Take a screenshot, children. Please take a screenshot. This is assignment.
Please hold it for 2 minutes, ma'am.
Yeah. I think I'll share the picture. Not able to take a screenshot?
Yes, ma'am.
Okay, okay. Let me share the pictures. One second.
Thanks, ma'am.
Yeah, no problem. Yeah, next one. The population of a town is increasing at the rate of 5% per annum. The population of a town is increasing at the rate of 5% per annum. What will be the population of the town on this basis after 2 years if the present population is 16,000? So population increase in population works with compound interest, meaning now supposing something is the population at the beginning of the year and it increases by 5%. For the next year, let me just take an example, the same case here. So if the population at the beginning of 2001 is 16,000 and at the end of beginning of 2001, end of 2001, supposing the population increases by say 10%, so it will be 16,000 plus 1,600. So 17,600. 17,600 is the population at the end of 2001. So this will be the population at the beginning of 2002. So you can see that the it's like the principal value which keeps increasing every year under compound interest. In the same way here, the population will keep increasing. See, when there's an increase in population, the population will be different, will be more at the end of every year. And that value will be taken for further calculation, like we do in compound interest. So these are the practical situations where the formula to find the compound interest is used. So now in the formula we have two things, no, amount and principal. Amount and principal. Now here we have present population and population after 2 years. See, we are given the present population and we have to find the population after 2 years. In this question, we are given the present population and we have to find the population after 2 years. Now, which one is regarded as amount? Which one is regarded as principal? Always regard the latest one as the amount. Whichever is the latest one, that's the amount. So here between these two, which will be the latest one? The population after 2 years. Present population and population after 2 years. So the latest one in terms of time, which one is ahead of time? Population after 2 years. That's ahead of time, right? When compared to present population. So here the present population is taken as the principal and the population after 2 years, which is to be found, is taken as amount. Okay, so the formula is actually P amount is equal to P into 1 plus R by 100 to the power n. So amount here is population after 2 years. Population. Let me write it neatly, children. Sorry. Amount is equal to P into 1 plus R by 100 to the power n. Okay. So population after 2 years is equal to present population into 1 plus what's the rate? 5. Okay, let me write the formula first like this. So after 2 years is what we have to find. Present population is 16,000 into 1 plus R is 5 by 100 and time is 2. So these are the situations where the formula to find the compound interest is applied or used. It's increasing, no? So it will be 1 plus R by 100. If it's decreasing, it will be 1 minus R by 100. If there's a decrease, it will be 1 minus R by 100. Increase, it is 1 plus R by 100. And A is the one which is ahead of time. So here the two things are present population and population after 2 years. So after 2 years is ahead of the present population, right? So population after 2 years is the amount and the present population is the principal. The population of a village is 20,000. If the annual birth rate is 4% and death rate is 2%, calculate the population after 2 years. So population after 2 years, we'll have to find the present population is 20,000 into 1 plus R by 100. This is the rate. The growth rate is 2%. The growth rate is 2%. Okay, so R is 2 by 100 and the time is 2 because population after 2 years. So the time is 2. The population of a town was 16,000 3 years ago. I'll wind up with this one, children. The population of a town was 16,000, no, not 16,000, 1,60,000 3 years ago. All right. 3 years ago, the population was 1,60,000. If it had increased by 3%, 2.5%, and 5% in the last 3 years, find the present population of the town. So here we have population 3 years ago, and we have present population. So 3 years ago, present population. Say 3 years ago is now considering today's time. So it is 3 years ago is 2020. Now 2023, which is ahead of time, this one. So this one is the amount. Which one is ahead of time? 2023. This is the amount. This is the principle. So between population 3 years ago and present population, which is the latest one, present population, that is the amount. Population 3 years ago, principle. So present population is the amount is equal to population 3 years ago into, see, present population is the amount. So amount is equal to principle. Principle is the population 3 years ago. So instead of amount, we have written present population is equal to, instead of principle, population 3 years ago. So P into, you can see that the rates are different for the 3 years. So it will be, and it's increasing every year. So it will always be 1 plus R by 100, not 1 minus. If it increases in 1 year, decreases in the other year, then it will be like 1 plus R1 by 100 into 1 minus R2 by 100. Use plus minus, plus for increase, minus for decrease. All right, so it will be 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100. Everywhere the power is 1, because for each year we are finding. So the power n, the time is 1. So you don't have to show the powers. So amount is equal to P into 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100. So population 3 years ago is given 1,60,000 into 1 plus 3 by 100 into 1 plus 2.5 by 100 into 1 plus 5 by 100. Work this and you'll get the population, present population. And how do you handle 1 plus 2.5 by 100 children? Just shift the decimal point, It will become 25. So add a 0 here. So it'll be 1 plus 25 by 1000. Shift the decimal point, 2.5 by 100. If I multiply the numerator by 10 and denominator by 10 in your mind. Multiply the numerator by 10, 2.5 into 10, 25. Denominator by 10, 1000, 100 into 10, 10,000. Now cancel. 25 ones are 25, 40 times. All the children, thank you so much, Shreya, Surya, Lakshana, Aishwarya, Gayatri, and Dhyarni, for making it convenient to take up the class at this time from 8:30 to 10:15. Thank you so much. And yeah, that's it for today's session, children. Thank you once again. Good night. You may leave the call.
Thank you.
Okay. I'll share the further instructions on WhatsApp, children. Okay. Yeah. Thank you, children.
Okay. Thank you, ma'am. Good night.
Thank you. Good night. Thank you. Good night.